12 every single 12-2 angles and angle measure. So this angle is all about angles and angle measure and how to draw them. So first, let's talk about an angle. We draw them on a normal XY plane. As you can see, there's an X, there's a Y. It's a normal XY grid. So if I give you a normal XY grid, that's how we can draw angles. So let's go over a couple of definitions. In standard position is when we draw on here. So it's called standard position, like this. We always start on the positive X side. That's the start of our angle, right there. That's called the initial side. Or spelled legibly, right there. Right, now here's the idea. When we draw our angle, if it's a positive angle, we're going to go up from here. So if I say an angle like, we want an angle like 100 degrees, well, here's 0. This is halfway, that's the right angle there, so 90 degrees. So 180, 270, and then you go around again. Just keep on adding 90, right? Just right angles everywhere. You get 360, a full circle, 360. If I want to draw 100 degrees, you just go, okay, 100 is between 90 and 180. And this right here is 100 degrees. Now that side we ended up on, that's called the terminal side. That's where you stop your angle. And that's how drawing angles works. So keep in mind, if you're positive, you go up. So we always start on the positive x-axis. Positive, we go up. Negative, we go down. So again, always start there. Positive, go up. Negative, go down. So let's draw a couple. So this first one, then when we draw 80 degrees in center position. So again, center position means we're going to start on the positive x-axis. That's all that means. We're going to start right here. That's how we always start our graphs. Now I want to draw 80 degrees. Well, this is 90, right? This is 180. 180 is a straight line. 90 is halfway. 80 is a little less than that, so we're just going to go like this. It doesn't have to be perfect. All I care about is in the correct quadrant. That's all I really care about. That's 80 degrees. About. Negative 105. I'm going to try and be tricky. So here's 0. Now negative, we're going to go down for negative. It works the same way. This is 0, negative 90. Just put little degree signs everywhere. There we go. Negative 180. Negative 270. And then negative 360. Key thing to keep in mind with this guy is all about orientation, right? Negative, we're going down. We're moving like this, like counterclockwise. That's actually clockwise. Clocks go down. Here's counterclockwise, right? So when we go positive, we go up, we go counterclockwise, move like this. So that's the idea. So if I want negative 105, here's negative 90, here's negative 180. It's in between these two. Again, I just care to get in the correct quadrant. That's all that really matters to me. Negative 105. We'll deal with the rest of that later. Let's draw a couple more center position. 180. So 0, 180. I want to draw 140. What's up for me today? Right, so again, I think I care most about is what quadrant you're in. So we're starting here. It's a positive, we're going to go up. Here's 90, here's 180. We're in between those two. We should be in quadrant 2. Remember, this is quadrant 1, quadrant 2, 3, and 4. So you should be in quadrant 2. Negative 60, 0. Now negative means we're going to go down. So negative 90, negative 180, yada yada. But negative 60 is in between these two. So this is quadrant 4. That's negative 60. So quadrant 4. Let's do 390. That's a little interesting. So here's 0, here's 90. I always write decimals. Degrees. So 180, 270, 360. Now if you notice, I'm still not far enough. I can get to 390. I'm a little short, so let's keep on going. The way you keep on going, just like the way you always do, just keep on adding 90. So 360 plus 90 is 450. You can add 90 if you want. Keep on going. 540. This is also 630. This is also 720. And again, you can keep on going around and around and around as much as you want. So with that in mind, 390 is just going to be between 360 and 340. So your graph actually goes all the way around and then goes an extra value right here. And that's what 390 would be. It's in quadrant 1. It goes around first, but it's in quadrant 1. If you look at it, how much extra did I go? 390 and 360? I went 30 extra. That's actually the next thing we're going to talk about. That 30 degrees is essentially equal to 390 degrees in one context. Right? But these are very similar. They're the exact same angle opening, just 390 goes around in a circle. First. So that's what coterminal angles are. Coterminal angles are angles that have the exact same angle measurement from a standard form. So like right here, 60 degrees is the exact same thing as saying 420, just go around in a circle first, which is the exact same thing as saying negative 300. Those are all coterminal angles. You're just going around in a circle. So any angle that has the same terminal side is called a coterminal angle. How do you find them? Well, it's actually very simple. All we're doing is going around a circle. The circle is 360. So to find a coterminal angle, all we're going to do is add or subtract 360. That's all it is. So let's do a couple of examples. So find an angle with the positive measure and an angle with the negative measure that are coterminal to this angle. So we have 25. We want to find an angle that's a positive coterminal angle. We're just going to add 360 to this. And we're going to get 385. And that's a coterminal angle 25. They're going to have the same terminal side. Want to find a negative version of it? Just subtract 360. And I'm going to get negative 335. And that's how you find a coterminal angle. Let's skip this one because it's the same thing. Let's do this one. They want me to find a negative coterminal angle? Well, I'm already at negative 100. So let's subtract off another 360. I get negative 460. Let me actually draw this one. So negative 100, ready to go down. There's negative 180. Negative 100 is over here somewhere. They're saying if you went around another circle, you just went full another circle, you'll have another. That'll be negative 460. Now you want a positive coterminal angle? Just add 360. And you get 260. So that one, if I was going to draw it, going proper way, here's 0, here's 90, here's 180, here's 270. So 260 is in this quadrant, the exact same spot. So those are the coterminal angles. Now the next thing is, now that we're all good with angles, hopefully, we're going to talk about what radians are. All radians are another measurement of angles. Just like how if I give you a length of like, hey, that's about 1 inch. You can also say that's about 2.5 centimeters. Same thing with angles. If I have this, and that's supposed to be a straight line, this is 0, 180, and 360. You're saying, hey, when you go around a full circle, that's 360 degrees. But in radians, we use 0. We use half the circle as pi. And then if that's 0 to pi, this will be halfway, which is pi over 2. Half of pi. We go around again, and we get 2 pi. And this is halfway between those two, so 3 pi over 2. Why do we have radian measure? Because it's, like many things in life, it actually makes math and physics a lot easier in radian measure than it is degree measure. There's things that are so much simpler to measure in radian measure. And that's what a radian circle looks like, a radian degree counter looks like. We're going to start working with that. So first, let's talk about how to convert. Right, like right here, and here's the key. How you go from one to the other. We know that 180 is in reference to pi, right? Pi is not 180, pi is 3.14. But the way we measure angles, 180 is essentially pi. So if you want to go from degrees to radians, well, you have degrees, you want radians, we're going to use the exploit. Radians usually have a pi in it, so I want pi, so it's going to be pi over 180 equals my radians. So if I give degrees and you want to go to radians, just multiply by pi over 180. That gets you the pi that radians generally has. When you go the opposite way, when you have a radian, which generally has a pi, you want to go to degrees, you want to get rid of that pi, so you flip it. And that gives you degrees. Right? All coming from right here. we know 180 is equal to pi in degree measurement. So all we're doing first is just convert a couple things. Hey, this is degrees. Let's put in radians. So I'm going to get my 120. I'll multiply by pi over 180. If that helps, this is over 1 also. So I get 120 pi over 180. You can reduce it. 12 pi over 18. And if you're good at math, you can reduce more, divide both by 3. And you get 4 pi over 6, which is actually 2 pi over 3. But that's what 120 is. 120 is in radians. So if I give you 2 pi over 3 now, you should be able to graph it as 120 degrees. Same spot. We're not going to do much of that though. The next one, same idea. Oh, now you have radians. You want to go to degrees. So radians to degrees is you flip it. Right? Degrees doesn't have a pi sign usually. So multiply by the pi on the bottom. These will cancel out. And you get whatever negative 3 times 180 is over 8. And not going to do that. Right? These are the same thing real quick. So here's the radian. We want to get in degrees. So you multiply by 180 over pi. These actually cancel. And you get 180 over 4. Which is 45 degrees. If I was doing this one, 225, I am in degrees. I want to get radians. So I'm going to multiply by pi over 180. Right? You want that pi in the thing now. Multiply across, 225 over 180. If you want to reduce that, you get 5 pi over 4. So that's how you convert from one to the other. Next thing though, let's talk about something that's important. That's really important. Reference angles. Now the truth is, you need to know how to convert from one to the other because it's helpful. But you're not going to do it a lot. I'm going to want you to just know how to graph and do stuff with radians. So the first step to that is understand what a reference angle is. And all a reference angle is the angle from the terminal side and the x-axis. Super important. It goes to the x-axis. So what do I mean by that? Let's say I give it that 120. If I want to graph it, I'm like, okay, here's 0, here's 180, here's 90. 120 would be in between these two. The reference angle is it goes to the x-axis. You're not going to go here. You're going to go down to here. So what angle does that make? Well, this is 120, this is 180. How far apart are they? 60 degrees. That's my reference angle. So that's what reference angle is. It's how far is your angle from the x-axis. Has to be the x-axis though. Don't ever go to the y. It's always the x. So let's do a couple examples. First, let's talk about degrees. So we do it just like we talked about. So we want to graph it first. Here's 0. It's a negative, so we're going to go down. So here's negative 180. Negative 90. Negative 110 should be in between these two, right? It's in between negative 90 and negative 180, so like this. That's my angle. This part's negative 110. But I want the reference angle. So again, I want to go to the x-axis, which is right here. That's the reference angle. In this case, you're at negative 110, and you got to go all the way to negative 180. Just think about how far apart are they? They are 70 apart. Let's do a couple more. Convert the reference angles for degrees, and we'll talk about how you do it radians. So 300, 0, 180, 90, 270, 360. So 300 should be in between these two somewhere. Again, I really don't care as long as you just draw it. So that's 300. Now the reference angle is this part right there. How far is it from the x-axis? These are 60 apart. One more with degrees, and we'll talk about how to do radians, which is actually a lot easier in some contexts. So here's 0, here's 180. 150 should fall in between these two. We're starting from here. But I want the reference angle. That's this guy right here. So what you find out is just figure how far apart 115 and 180, just subtract them. And you get 65. Okay, so let's talk about how you do radians. Now radians are very specific. If I ask you for referencing for radians, it's always going to be either 3, 4, 2, or 6. So what happens when it's one of those? So what happens when it's some value over 3, some value over 6, some value over 4, which are the big ones. Well, one way to think about it is that pi is like 180. As you mentioned earlier, so you have 180 over 3. 180 divided by 3 is 60. Anytime you have one of these, I don't care what's on top. What's on the bottom tells me what the reference angle is. It's 60. Same here. This is 180 over 6. You divide that, you're going to get 30. And pi over 4 is going to be 180 over 4, which is 45. And no matter what you do, you're going to have to know that. Coming up, we're going to use this a lot. Another way I honestly like to think about this is the pizza way. Don't laugh. I think about like a pizza. So if I have a pizza, I know because a lot of people get these mixed up. Why is it over 630? Why is it over 360? Well, think about it. If you have a pizza slice, pizza and you divide it by 3, I might get a pretty big slice. That's right. So when you divide by a small number, you actually get a bigger slice. When you divide by 3 people, you get more of it. When you divide by 6 people, now my pizza is small and I'm starving. And it's pizza, so I love it. Right, so in that case, you have a small slice. You divide by 6, a lot of people are sharing. And then divide by 4 is like Goldilocks zone. It's like perfect right in the middle, whatever. It's also 4 and 4. Anyway, that's how I find a reference angle with radians. I'm always going to give you either 3, 6, or 4, sometimes 2. And this is one of those things. So this one, again, I don't care about the top. Oh, it's over 3 into radian. It's going to be automatically 60. Big slice. Over here, again, I don't care about that to negative 3 power 4. I think go somewhere. It's over 4, so it's automatically 45. So that's how you find the reference angle. Now let's talk about the number on top. That tells you what quadrant it's in. So we have to know how to start graphing radians. That's what we're going to do next. We're going to practice drawing radians in standard position. Right, we already know how to do degrees. Let me erase some of this right here. Right, if I ask you to graph, just a little recap. Right, if I ask you to graph 300 degrees, you'd be like, oh, it's easy. Do this. So 180, 270, 360. 300 be in here somewhere. Now let's talk about how to draw radians. And there's one key to drawing radians. That is use common denominator. And what I mean by that, it's really right here. This means 0, this is always going to be pi. But you can make this pi anything you want. You can make it 4 over 4, because that's still 1 pi. You can make it 3 over 3, 6 over 6. And then from there, we're going to move a little up and a little down. So common denominator is the key. So let's do this first one, pi over 3. Here's another hint. Anytime it says a 1 on top, then it's automatically quadrant 1. So pi over 3 is just going to be in quadrant 1. Here's 0, here's pi over 2. Pi over 3 is in quadrant 1 somewhere. And there I go, that's how you draw it. If I want the reference angle, it would be, it's over 3, so it's automatically 60. The next one, that's where it's starting to get fun. 5 pi over 6. So it's not in quadrant 1. The way I do this is like this. So 5 pi over 6, let's look at the denominator. That's all I really care about. So I'm going to make a common denominator, make this 6 over 6. So 5 pi over 6 is where is it at? Well, it kind of goes like this. We start here. We're going this way. I haven't reached 6 over 6 yet. I'm 1 short. I'm 5 pi over 6. So I'm going to be over here. That's where 5 pi over 6 is. Right? It's a little short of 6 over 6. Next one builds on that. if I know 5 pi over 6 is right there, where's 7 pi over 6 at? Well, I'm glad you asked. Or didn't ask, I don't know. We're going to do the exact same idea. 7 pi over 6, let's use common denominator. Let's make this 6 over 6. And same idea, we're starting here, right? Going this way. That's 6 over 6. I actually got to go a little past it. I got to go to 7. So let's go a little further down. And that's 7 pi over 6. And that's the way this is going to work. We're going to do some way more in a second. But the general idea is this. Let's say I give you this. This is pi. You can make this anything you want. So let's make it over, we already did 6, let's make it over 3. 3 over 3. What does that mean? Well, quadrant 1 is always just pi over 3. Quadrant 2 here, we're going this way. I haven't reached 3 over 3 yet, so we should be a little short. So just go a little less of it, and this is 2 pi over 3. We haven't got to 3 over 3 yet. When we keep on going, we're going to go a little past 3 over 3, and we're going to go to the next one, which is 4 pi over 3. Then we go over to this one. Now this is 3 over 3. The reason that's 4 pi is because you go a little past 3 over 3. So if I have to go around and then around again, it's another 3 over 3, which is 6 pi over 3. Right? 3, then another 3 is 6. So if you haven't got there yet, you're a little short. You're 5 pi over 3. And you can keep on going. But that's the general idea of how you graph in radians. It's all about the keys right here. Make that a common denominator. Oh, one less, one more. You need more of that? Go around the circle again. Oh, one less, one more. You just keep on going and going and going. So let's try these to make sure we know how to do this. So this first one here, 11 pi over 6. Here's 0, here's pi. 11 pi over 6, well, I'm going to make this 6 over 6, common denominator. That makes this would have been 5, this would have been 7. I got to get up all the way to 11. So this is 6 over 6. If I go around in a full circle again, that's 6 over 6 plus 6 over 6, which is 12 pi over 6. In this case, it's 12 over 6. So I want to go to 11, right? So 6, 12, I'm a little short. I just need 11. Should right here in quadrant 2. Yeah, that's all I care about. I care you know what quadrant it's in. Look at the next one. It says 3 pi over 4. We'll just roll fast. Here's 0, here's pi. Common denominator, 4 over 4. We're going this way. I only want 3 pi over 4. We haven't reached it yet. It's a little short. So that's 3 pi over 4. Again, coming from this thing though. So that's what 3 pi over 4 is. Negative 7 pi over 6. So here's 0. It's a negative. We're going to go down. So going down is negative pi. Common denominator, so negative 3 over 3. If I go around again, it'd be negative 6 pi over 3. And I want to get negative 7. So I actually go a little past it. Now again, we're going negative. So a little further is this way. That's negative 7 pi over 3. And that's how you draw a radian measure angles. Last thing we're doing today, arc length and central angle. So this is a central angle. It's an angle that goes hits straight to the center of the circle. This angle right here is called an arc. It's called a central arc. So what if I want you to find the arc length of something? How long it takes to this length right there? Well, there's a formula I'm going to give you. This formula I will give you and let's use all the time. It tells you how the arc length is, or every sector is. There's one catch. These formulas only work in radians. There's formulas for degrees, they're a lot bigger, and I'm not going to give you those because I want you to know how to use radians. This is only for radians. So if I want to find the length of the arc, theta is in radians here. So I got to convert it if it's not in radians already. So look at the first one. Find the length of the arc, round to nearest hundredth. So arc length, just using the formula, is this. So we need a couple things. We need the arc length. Hey, they told me 10 pi over 9. How lucky. and I need the radius. In this case, the radius is 27. Right, radius is from the center to the end of the circle, so 27. Multiply these together if you want, and you're going to get 30 pi. I don't know why it's over there. That's how you use arc length. Using these formulas, plug it in. Let's do another one, and then we'll stop. A circular diameter has a circle has a diameter of 9 centimeters. So here's my circle. This is 9 centimeters. Find the arc length if the central angle is 60 degrees, not nearest 100. So they're saying, hey, there's an angle here that's 60 degrees. Find the arc length. So I'm going to use the formula. L equals R theta. Now, again, this theta has to be in radians. Right now I have degrees, so I got to convert that. I got to go from 60 to radians. Now all we do is use the formula. Right, I want to go from degrees to radians. It is your degree times pi over 180. And that gets you to radians. So in this case, my angle is 60. So 60 times pi over 180 gets me 60 pi over 180, which would get me 1/3. So that's my radian measure, 1/3. So if I'm using this formula, it's going to be L equals my radius, which is 9 is the diameter, so 4.5 is the radius, half of that, times 1/3. And you get an answer. And that's the idea.